Okay, so in this video, we will consider a special case of L'Hopital's rule when you have a limit yielding a case that is of the form 0 times infinity. If you remember, to apply L'Hopital's rule, your limit must give you a case that is of the form either 0 over 0 or plus or minus infinity over plus or minus infinity. So if you have a case like this, 0 times infinity, you can't directly apply L'Hopital's rule, but if you tweak, if you rearrange the expression, then you can transform 0 times infinity into either 0 over 0 or infinity over infinity. And you can think of it in two ways. Suppose you have 0 times infinity, and you send the infinity down, right? So if you divide by 1 over infinity, same as multiplying by infinity, but 1 over infinity is 0, and you get a 0 over 0 case, sending the infinity down. What if we do the opposite? What if we send the term that's giving you a 0 down? So if you divide by 1 over 0, multiply by 0, but 1 over 0 will give you either plus or minus infinity, and once again you can use L'Hopital's rule. So the idea is just that simple. If you have a product in your limit, giving you a 0 times infinity case, you can send either a term down. In either case you'll get 0 over 0 or infinity over infinity, allowing you to apply L'Hopital's rule. Let's consider two examples of this. Letting x approach 0 from the right, so x is shrinking to 0 but always positive, and x times e to the 1 over x. So as always, we look at our case. As x shrinks to 0, x shrinks to 0. Now as x shrinks to 0 and positive, 1 over x will shrink, well, sorry, not shrink, but approach positive infinity. 1 over something that shrinks to 0, so 1 over something really, really small is going to be really big. So we'll have e to the infinity, which is itself infinity. And so we have a special case 0 times infinity. We'll send the term x on the bottom, and if you ever make a mistake, or if you ever send one term down, whether it is the infinity term or the 0 term, if you don't pick the right term, the limit will get very unpleasant very quickly. So e to the 1 over x we keep on top, over, and of course if we send x down we must send the reciprocal, because if we divide by 1 over x, same as multiplying by x. And then we consider a case, as x goes to 0, from the positive side, 1 over x goes to infinity, e to the infinity is infinity, over, as x goes to 0 from the positive side, 1 over x goes to positive infinity. And so we now have an infinity over infinity case simply by rearranging the expression, and now we can apply L'Hopital's rule. Sorry, I was not applying L'Hopital's rule here. I simply rewrote the expression. Now that we have the right case, we can apply L'Hopital's rule. I was getting ahead of myself. So we differentiate. We have to apply the chain rule here. The derivative of the exponential is itself, times the derivative of 1 over x. Don't use the quotient rule here. Think of 1 over x as x to the negative 1. And if you differentiate, you'll get negative x to the negative 2, which is of course negative 1 over x squared. Over the derivative of 1 over x again, negative 1 over x squared. The great thing of course now is that this becomes trivial. A term over itself cancels to 1, and we're left with the limit as x goes to 0 from the right of e to the 1 over x. 1 over x goes to infinity, e to the infinity is infinity, and so the limit is infinite. Now, something is worth mentioning here. In our previous video we said that if the new limit from L'Hopital's rule exists, the original limit also exists and they're both equal. Now this limit does not exist, it blows up. But the result is a little bit more general. If the new limit exists, equals positive or negative infinity, so does the original limit. So the new limit blows up, the original limit also blows up. Let's consider a second example. This one's a bit more interesting. So we let x approach negative infinity, and we take the ln of x squared plus 1 times e to the x. So we look at our case. As x goes to negative infinity, x squared plus 1 goes to positive infinity, and ln of positive infinity is positive infinity. Now, e to the x, as x goes to negative infinity, e to the negative infinity is 0, so we have an infinity times 0 case. And we'll send the exponential on the denominator, and I'll simply write, you can think of it as 1 over e to the x, but in simpler terms, thinking of the derivative next, e to the x, if you send it down, you negate the exponent, so just e to the negative x. So we already know that this term goes to infinity, over, now as x goes to negative infinity, negative x goes to positive infinity, and e to the positive infinity is positive infinity. So we can now apply L'Hopital's rule. Differentiate the numerator. The derivative of ln is 1 over the argument, so 1 over x squared plus 1, times by the chain rule the derivative of the argument, which is 2x, over the derivative of e to the negative x. Differentiate the exponential, you get the same function back, times the derivative of negative x, which is of course negative 1. Before we look at our case, we can clean this up a little bit. A negative 1 times 2 is negative 2, so we'll have negative 2x on the numerator. And if we send this term down, x squared plus 1, because again, if you multiply by 1 over something, you just divide by the same expression, and we have an e to the negative x. Now there's two ways we can solve this limit. We could look, and I will leave this up to you. If you look at your case, as x goes to negative infinity, negative 2x goes to positive infinity, over x squared plus 1 goes to infinity, e to the infinity goes to infinity, so we have once again an infinity over infinity case. And so you could apply L'Hopital's rule once again. If you do so, differentiate carefully using the product rule here, and you'll find the answer. What I want to show you now, in this case we can do a little simpler. If we simply divide top and bottom by x, and I will leave the second half of the solution using L'Hopital's rule up to you. So as I've said, I'm going to multiply the expression by 1, being 1 over x, as 1 over x over itself is 1, and now I will distribute with this term and with this term. So x times 1 over x is 1, so we're left with negative 2 on the numerator, over x squared over x is x, plus 1 over x, times e to the negative x. And now what's interesting, by this simple algebraic manipulation, the limit is essentially trivial. If you look at your case, negative 2 is constant, always negative 2, over, now as x goes to negative infinity, 1 over x shrinks to 0, and the x goes to negative infinity, so this term approaches negative infinity, And as x goes to negative infinity, negative x goes to positive infinity, e to the infinity is infinity. So we have here negative infinity times infinity is of course negative infinity. And the answer is obviously 0. A constant over something that is larger and larger and larger is shrinking to 0. Now of course at this stage, if you don't think of this, it's okay. Again, make sure that you complete this other solution. You have an infinity over infinity case, apply L'Hopital's rule a second time, and you will also arrive at the same answer. That's it.